Hello and welcome to my next video. Mr.NET is here and today I'm going to explain the interpreter pattern. This pattern is a part of the Gang of 4 and if you are interested into this pattern, watch this video. The things what we need for our pattern is, firstly we have a client and an interface. We called it the iExpression interface. And this interface provides one method, the interpret method. Then we have a context, and the context is responsible to manage the state of the expressions. And then we have different expressions which are implements the iExpression interface. We can separate these the expression objects in two different expressions. One is the terminal expressions and the other is the non-terminal expression. The difference is that the non-terminal expression contains references to other expressions. Why we use the interpreter pattern? For that we look into a little example. We have here a client and this client has a string expressions and this string contains many chars. We see 1 plus 2 minus 3. And the client wants to translate this string into an integer value with 32 bits. For that we create for each char in the string a own object. We see that the numbers can match the number expression, so we create for each number a own instance. This is in my example the number expression and this is a terminal expression. The plus, from the plus we create a plus expression instance. This is a non-terminal expression because it has a left expression reference and a right expression reference. And also the minus has a own object, and from this object we create a minus expression instance. It has also a left expression reference and a right expression reference. So we use this pattern when we want to translate one data type or one data syntax into another data syntax. Now we look into the source code. Firstly, I create my objects. So I have a public interface and I call it the iExpression interface. And this interface provides a method which returns me a type integer and the method calls interpret. Then I create my concrete implementations for this pattern. For that I create a public class, the number expression, and the number expression implements the iExpression interface. So we also have to implement the interface. Then I create a public class, the plus expression. This class also implements our expression interface, and we also have to implement this method. Then I copy this line and paste it here and change the name plus expression to minus expression. So now I have my 3 implementations of the iExpression interface. The next step is to implement the behavior into our concrete implementations. If we look into this diagram, we see then that the number expression represents only a number. So in my number expression, I implement a constructor called number expression, and as an argument I get an integer value, I call it value, and this object contains one field, private integer type, I call it underline value, and if I instantiate this type of object, I say that the underline value is the given argument. And now we have the interpret method. This method returns us an integer value. So the number expression, it is enough that this expression returns us this value here. So I say return underline value. The next two objects are has a little bit more behavior, because if you look into the diagram, we see that the plus expression here and the minus expression here both has two references to other expressions. We have the left expression and the right expression. So also here I create a public constructor plus expression, and as an argument I get a left expression from type iExpression, and I also get an expression called right expression. And I also need two private fields, private expression, left expression, and the second field is the right expression. And if the client instantiate the plus expression, I say underline left expression is the given argument left expression, and the right expression is the given argument right expression. Also the minus expression has two references, so I copy these two lines here and paste it into my minus expression, and the minus expression needs also a constructor, so I copy this constructor from the plus expression and paste it into my minus expression, and we have to change the name plus expression to minus expression. And now the interpret method has to return an integer value. So this is the plus expression, and the behavior is to do an addition between two expressions. So I say return underline left expression plus underline right expression. We see this is not working because I can't do an addition between these two objects, but these objects are iExpression objects, and the iExpression object has the method interpret, which returns me an integer value. So I call inside my interpret method from the plus expression return underline left expression interpret plus underline right expression dot interpret. I use it in brackets, so now I can copy this line here and paste it into my minus expression, and the minus expression does not an addition, it is doing a subtraction between these two references. The next object what I have to implement is the context. The context is a public class. I call it the context. And this context manages the state for all expressions. So I need for each different expression type a own stack. For that I say private stack from type I expression. That's the expression underline stack. And then I need a private stack from type string, and that's the operators underline stack. So, and as a client, I want, for example, translate this string here into an integer value. So I say I offer the client a method public int. This method returns me an integer value, and I call this method insert expressions, and the argument is a string. I call it the expressions. And inside this method I try to pass it into an integer value. First I have to iterate through each cyan. So I say for integer with start value 0, and the length is the length of the expressions. Expressions dot length. Now I can access with my variable I each char in my string. And firstly I have to check which char is the next in the string. So for that I use a switch statement, and the switch statement needs an argument. The argument is a string. I call it the single value, and the single value is the expression on the position I. Dot toString. And with this single value, now I can use my cases. So if this single value is a plus, then do this. If this single value is a minus, then I have to do this, and the default value is a number. So when I get a plus, I say operators stack dot push the single value. Break to stop this switch statement here. If I get a minus, I say operator stack dot push single value and break. and if this single value is not plus or minus, then it has to be a number. So I use if integer with 32 bits dot try pass. So I pass this single value into a new integer value. I call it the number. And if I can pass this value to a number, I create with this number a new iExpression object. And this expression object is the number expression. And the number is given to the constructor of the number expression. After I create the number expression, I insert this expression into my expression stack. So I say expression stack dot push the expression. And then I use the break keyword. After we insert this value in the concrete stack, I can check how many expressions or how many signs, how many chars we have checked in our switch statement. And if I have in my expression stack two numbers and my operator stack has one operator, I can create with this three chars here a own expression. So I say if the operator stack dot count is 1 and the expression stack dot count is 2, I can create a new expression from these three chars. So for that I use a switch statement, and in the operator stack it depends what for an expression I want to create. So if this string in the operator stack is a plus, I create a plus expression. If it is a minus, I create a minus expression, and the default is nothing. Break. So if the operator's stack has a plus, I create a new expression object. I call it the plus underline expression, and this is a new object from type plus expression. And this object needs two expressions for the constructor. And we know that our expression stack contains two expressions. So I say iExpression left expression is expression stack dot pop. And we have to give attention on the order, because I have two elements, and the first element in the stack is the left expression. So if I use the pop method on this place here, I get the last inserted element, and that's the right expression. So this here is the right expression. Then I copy this line, and this line here is the left expression. And these two expressions I use for my constructor, left expression and right expression. Now I have here my plus expression, and I insert this expression into the expression stack. So I copy this line here, and in the minus case I create a minus expression. We see I have here a problem with my names, so I copy these two lines here and create here my fields or my variables. Then I can delete the type declaration in front of my names. So now we have here a second plus expression. I call it here the minus expression, and I insert the minus exception into the stack. Then I use the keyword break to finish the switch statement. If I pop my two expressions from the stack, the expression stack is empty. So in this line, when I push the new expression into the stack, I have only one element in the expression stack. So after I iterate through all signs in my string, I have to return an integer value. And we know that our expression contains a method which returns an integer type. If I perform this if body here, our expression stack contains one expression. I can call expression stack dot pop point and call the method interpret. So now we can try it in the console. For that I use a while loop, and inside this while loop I say string input is console dot readline, and this input, and for this input this input I use in my context, so I say int result is new context dot insert expression, and my expressions is the input. And then I print the result here, console dot writeLine input is result. So I save it and I start the program. We have here hello world, and now I try 3 plus 3, enter, and I get the integer value 6. I try 3 plus 3 minus 9, and I get the result minus 3. it seems for me that this pattern or my program works. The last point is I implement in my expressions some additional information. So I use console write line, and in the number expression I print to the console the number expression and the value of the current number expression. In my plus expression I print the information plus expression, then I call the left expression dot interpret method plus, I copy this, the right expression interpret. So I copy this line, and also my minus expression gets this method. The name is minus expression, and here is also a minus. I save the script, I start the program. 1 plus 2 minus 3. Firstly, in my context, I instantiate a number expression, the number 1. Then I instantiate a number expression, number 2. From these two expressions I create a plus expression, 1 plus 2. Then I instantiate in my context a 3 expression, a number expression with the value 3, and with the plus expression, or the result of the plus expression and the value 3, I instantiate a minus exception. So that's the interpreter pattern. I hope I explained it well for you. If you have some information for me, please write this into the comments. Give me feedback so I can improve my videos for you. And if you like this video, please subscribe my channel, and hopefully I see you in the next video. Bye.